And let's get started. So first of all, welcome to today's webinar from my side. It's a second webinar in our 6.0 series. Today it's about the supply chain designer, one of our new apps that we released beginning of February. It's part of the premium tier, and so lots of interesting use cases are behind. So the app is about multi-tier network flow optimization. What this means, and also in detail, we will learn in the next 60 minutes. To give you a quick overview, what is planned for this webinar. So the idea is to give a general introduction in the new application, what can be modeled, which use cases can also be tackled, and also how to do it. So this means we have also prepared a little use case where we would like to demonstrate the capabilities of the application and also how to do it. So this means it will be also a mix between a few slides to get an overview, but then also we will directly jump into the tool and also make a deep dive in the modeling itself. So that's what we have planned for today's webinar. Very happy that you made it, right, and also take the time to go in there in this new applications or in this new application. And so first topic. Now let's see. Give me a second. So there should be the next slide. Perfect. Supply chain designer. What is it about? So it is determine the cost optimal product flows through a multi-tier network. So this means in terms of how you model the network, it is quite flexible. So most probably you know our other applications in this area, and there we have a predefined network structure. So that's a bit different here. So we allow having as many location layers or as many layers more or less as you want from a modeling perspective, and also the way how you connect them. It's up to you as a modeler. And so also one big difference is now we have also the multi-product case in there. All our other models are more or less single product models. That's a bit different. So this means we have this product level in where you then also can define the constraints on these products. And we have also a very interesting set of constraints that can be defined by the modeler itself. So this is related to factories, warehouses. So you have minimum, maximum constraints, conditional minimum constraints. What this also means in detail, we will see in a few minutes. There I have then also prepared so this example that makes it a bit more practical to see how this works. And also a very interesting topic is the so-called path control element in there. It's more or less a possibility how the user can also define valid or non-valid paths for different products. That's especially interesting, for example, if you have something like hazmat or some cold chain requirements, then you can define this path for different products, and then also more or less tell the optimizer what is valid and what is not valid to consider. In terms of use cases, it's quite flexible. So for sure. So this multi-product flow optimization, it's a central use case. Also the identification of capacity bottlenecks. So we have there also this concept of this penalty cost in there. So the optimizer will also tell you, hey, at which location it would be good to have more capacity if it is not sufficient. And also you can also take this multi-supplier sourcing decisions. That's also something that is new. All in all, it is a kind of app where you as a modeler decide how the final model looks like. This is I would say, a huge benefit, but also comes with the topic that you are also there more or less responsible how you would like to model your situation in there. That can be in the beginning also a bit tricky. What our recommendation is to start small, perhaps also with a simplified version, and then step by step adding more complexity, adding more constraint. But it's always good to have there the full picture and a deep understanding of what you would like to model. Coming now also to the use case. So it's a fictional company, right? So called Chemtech Solutions. That's what we have in there is more or less a network of a chemical manufacturer with 4 plants across Germany, Switzerland, Austria, and I think it's Czech Republic, not Poland, on the map. Then we have 18 customers, or I would say demand locations in 9 different countries. We have 6 product families, and we have 900 tons of annual volume. We have different products, so this means also we have hazmat, climate sensitive, and clean room products in there. And what this then also means, and exactly, and how this is then also translated in the model, we will also then see a bit later. The question or the questions I think we would like to answer multiple is, so we have a 4-layer supply chain. So we start at the sources, so the supplier, then we have a central or the plants more or less. Then we have so this central distribution centers, we have regional distribution centers, and we have the final customer layer. And the decision we would like to make is what is the right regional which are the right regional customer locations or locations for so this RDCs. And for sure, then also what is the optimal flows of the goods, of the products through the network, and what is the cost optimal configuration, also considering all the other constraints. So this means we have capacity constraints, we have minimum order quantities in there, and also some other capacity constraints in the warehouses itself. To give there a quick overview, so this 4-tier network, so the plants layer, the central DCs, regional DCs, and the customers. We have there now the connection between the different layers, plus we have then also the possibility to deliver direct. So far in this example, we will also see we connected all locations of 1 layer with all the locations of the next layer. This is a possibility, right? So we did it in this smaller use case example. When it comes to bigger scenarios, what we also recommend is to be there a bit more precise how to model it. You're also completely free. You cannot only connect so full location layers. You can also do this on a location level and be there more precise which relations are possible and which ones are not possible. So this, first of all, helps you because it makes the modeling more realistic. And it also helps the optimizer behind to be more efficient, because we can then also cut away more or less parts of the solution space that helps the optimizer to find the optimal solution much faster. In this case, I also noted this down. We have the central DCs. There's no decision to be made if they should be opened or not. So this is more or less fixed. And the regional DCs, the optimizer decides, plus then also for sure the flows, right? How this should look like is decided by the model itself. So far so good. Here is the map itself. Give me 1 second. I will share now this map and explain it to you. Therefore, I have to share another screen. Here we are. Hopefully you can see it. Yeah. So what we have here is the following. Let's do it like this. And yeah, so we have here the plants, right? So 4 plants in Germany, Switzerland, Austria, and I think in Poland, is it? Yeah. Then we have here the central DC. Yeah, okay, central DC was in Czech Republic, so the plant here is in Poland. That's correct. Okay. Then we have here also the regional DCs, Hamburg, Munich, and Zurich. And we have here then also the customers. I decided here to model now. I think in total we have 18 customers, especially in this multi-product flow models. What we also quite often see is that you don't model the final customers as a location in there. You could also more or less aggregate them to so-called demand points or demand regions, and then also consolidate the demand of a certain region behind a customer location to find out which points you should then also take in the model. One approach is also there to use the center of gravity analysis. For example, if you have thousands of end customers and would like to determine a smaller number of customers and would like to have representative location for each more or less demand area, then also the center of gravity approach is quite helpful in this case. And similar like this, it is also so in a real world scenario, you have more than 18 customers, but this can also be aggregated. Besides that, we also see here the flows from the plants to the central DCs in this case, and then there are some flows here so this is now already a concrete scenario. You see, then it goes to the regional DCs. In this case, Zurich is not considered. And so then we have here the flows from the regional DCs to the demand points or to the customers. That's more or less so the basic overview about the approach itself. Now let's go back to the slides. So here we are, back to full screen. Yeah, so I would like also to talk a bit about the decisions that can be taken in such a model. As said also in the beginning, so the supply chain designer is more or less a kind of modeling framework for these kind of problems. So this means it is up to you as a modeler to decide also what you would like or what the optimization model should decide. Okay, which decision should be made. So this means that's also perhaps a bit different compared to other apps in our portfolio. How you can do it in this case, we have there also multiple decisions that should be made. For sure, the objective is always minimize the total costs. What this then also means in detail, we will also see later in the modeling itself when we go to the Excel itself. We have to do a kind of binary decision per facility or per regional distribution center. Is it on or off? You also know that from other applications in our portfolio, like location planning or, for example, the network design apps. Also, this series is also always the topic. Okay, where should I have locations opened? How many of them should we have? And so these are the classical questions. So in this case, we only would like to make this decision on one layer. So the other layers, more or less, it's decided. So we can also flag them already as open. Then what is in this kind of model you can also consider it is a multi-product flow. So we also then decide, or the optimizer decides, what are the optimal product flows for the different products through the network. and making also this kind of design decision, which locations to use, but in the same model, also the decision, what is the flow of a product through this network that is then also more or less created. And I think especially for modeling real scenarios, so this path constraints is also very interesting and also important. It's an optional constraint, so it's not a must, but it helps you really to bring in there lots of realistic constraints and restrictions. So hazmat routing, clean room products, or for example, only a certain warehouse has cooling equipment, and then it's also clear that cooling products must be routed either exactly through this one warehouse or only through cooling warehouses, something like this. And for this kind of topics, you can do it. Plus, capacity constraints are, I think, interesting in the locations. So this was always we received also lots of feedback, especially in the network design apps, that we can only define capacity restrictions on the warehouses itself. That's absolutely also a valid point. At the sources, it is missing. And that's also what we now fixed there. So this means now you also have the possibility to define capacity constraint, minimum, maximum, on all locations, independent of the layer. So that's completely up to you how you would like to model it. And we also added there one, I would say, quite powerful capacity constraints. It is so this conditional minimum constraint. So that's the right naming for it. What it means is that either the optimizer or the solver achieves so this minimum, or it is zero, the flow is zero. And this is quite helpful in a warehouse itself when you say, okay, if you decide to use it, then you have to achieve so this minimum throughput, or you have to keep this warehouse closed, where it can also be quite helpful when you would like to model minimum order quantities on the supplier level. That's also quite interesting. There's always and also the decision, either you order a certain number or zero, but you have to make the decision. And this is exactly what is possible with this conditional minimum constraints. Good. All in all, finally, we are then also creating a mixed integer model that tries to find the global optimum, considering for sure all the constraints that we set. So this is also so this kind of models can also be quite big, right? Depends on you how big they are. From a complexity perspective, so it is also an NP hard problem. So this means also I would say it's quite easy also to model quite challenging problems that can also then take some time until we find either the optimum or a solution that is in a certain range to the optimum. Later, I will also show that to you directly in the product. How you can then also set a certain solving time and also set a so-called mid gap. More about that also later. One additional topic is, I didn't mention that so far, but I think that's also a very important point. It's about, I was always talking about product flows. So product flows, we have different products and they flow through the network, and that's also decided then by the optimizer. But we have, to be precise, we have two different types of flows in this model. The first is really the product flow itself, and the other, it is also called in the model service flows. What does this mean? A service is, for example, a truck of a certain type. It can also be an air connection. It could be a rail connection. It is a kind of service that is providing capacity on a certain relation. And also what comes with that, right? So when we provide service, for sure, there's then also some costs behind. And a product flow is only possible in this model if on relations that connect two different locations with each other, if there is also enough service capacity provided. And we will also see that later, then also in the output, that we have these kind of flow types. So we have the product flows, so product A, B, C, and we have the service flows, and you can translate it in practical terms. It's more or less a kind of vehicle or a truck that provides capacity. That's exactly what I have here under point 2, with this continuous product flows, and then we are using integer variables. So this means whole numbers to decide how many trucks do we need, of which type we need on which relation. Yeah, that's this point 2. Yeah, perhaps so far so good for the moment. So I'm asking my team, are there already any questions that we should try to cover, try to answer, or so far so good?
So
No
so far
questions
so
so
good.
far.
So we currently don't have any questions to address.
Okay, good. Okay, perfect. Then perhaps later. Good. There a bit, so this is this product routings. I would also like to keep this short. We have different products, so 6 different products, and then we have also defined here different constraints in this small example. So the constraint is called pass hazmat. It's only that only the CDC in Frankfurt has also the equipment to handle this, and there's no corresponding equipment in Prague. So that's this kind of constraint, and we have set this for certain products. That's more or less all, and you can then also limit the product flows to all the paths or all the ways through the network that you can define here. But we will also see this in a minute. I think only, so one slide. I think there we will now go exactly through. Then it's perhaps hopefully also a bit more interesting, right? So when we now jump directly into the product, go into the tables, and then I can also explain you how this is modeled. The flow is, I would say, quite similar, as you also know it from other applications. You connect your Excel data. For sure, you also have to validate data. To be honest, this is also a bit more, right? So you have now 6 different input tables, and make sure that the model is consistent and also valid. So this is this topic. Then you run the optimizer, review the results, can export it. But for sure, then also we recommend also then to run different scenarios, compare them, and also see then effects, what happens if you increase capacity, decrease capacity, add additional locations, and all these questions that come up. That's this topic. Now give me a second. Now I need my Excel. So perfect. Now you can see, or hopefully you can see my Excel. I hope also that this is big enough, and everyone can also read it. Perhaps I can zoom in a bit. Perhaps the first topic is when you open here our supply chain apps on the right side, you see here this new premium applications that are here. Hopefully on everyone's home screen. I'm not sure if this is automatically done. If not, you can just go here.
I think it's good to show this, Jan, because most likely when you adjust it manually, then it's not directly visible.
Yeah, good point. So you click here on this plus, and then you have here in network flow optimization. So this is the shipment flow optimizer. So Alex had this webinar, I think 2 weeks ago. So there you click then just on the star, and then it also appears on your home screen. And the supply chain designer, I think we have it in here. You see it, it's under the strategic network design category. It's in there. Also make sure that the star is here on yellow, and then you also have it here on the front screen. Perfect. Then we can go in. I think so. The principle, that's perhaps also the good topic. So the principal workflow is exactly the same. Here to the parameters, I will also then come later. What is also quite helpful and is here also the documentation, especially if you have then a question, hey, what does this column exactly mean, or are a bit unsure, how to model something, then I would really recommend go to the documentation and take a look there. So also there we invested quite some time to give precise information. As said, we have 6 different input tables. We have here locations, then the network structure, the product table, the path table, capacity profiles, and then also supply and demand. And as said also in the beginning, we can model multi-tier networks. We have a multi-product case. For sure, somehow we have to describe the problem. And then this, what is also different, it's really fulfilling more or less the demand based on a given supply in the network. So this app is not based on shipments, like the shipment flow optimizer, where you can put in your transport shipments from A to B. That is really you define supply and demand on a product level. That's from this perspective a bit different how this model works in general. All in all, let's now go through step by step. And also feel free, if something is unclear, write your question in the chat, then we can also directly take it up. And I try then also to answer your questions. I think that's extremely important that the model itself is clear. Locations, as said, right? So you have it in address in the long mode. So each location needs more an ID or a name that's in there. So there you can see what we have. We have now different plans. In this case, I decided to go with latitude, longitude. And we have here the layer itself. So this means we can, or we assign each location to a certain layer. In this case, it is I think quite simple. We have 4 different layers. We have plants, central DCs, regional DCs, and customers. In an extreme case, you could also have a separate layer for each location. So this means then also it's really also up to you how you group them together, or you have 2 plants, east, west, or whatever you would like to model. It's really up to you how you do that. Then we have this fixed column in there. I think you know it from the location planning and the network design apps. So this means if there is a 1 in there, then this location is more or less fixed. If a 0 is in there, then it is not fixed. So the optimizer can decide to open it or not to open it. I think the principle is exactly the same, like you know it from the other applications. We have a fixed cost. So this means when this location is used or it's opened, then the solver has to consider the fixed costs. And we have variable costs based on 3 different dimensions. So we decided to integrate weight, volume, and pallets. All in all, we called it weight, volume, pallets because this is, I would say, typical for, or these are typical dimensions for supply chain planning problems. Nevertheless, these are more or less numerical dimensions where it's up to you which values you fill in there. Only make sure that you're consistent. If you're using here, for example, a weight, it should also be used then in the corresponding capacity column of the vehicle table later, but we will see that. But more or less, you have 3 dimensions. You can fill them. Not all of them are mandatory. So you also see it here, pallets I did not use, so I just leave them empty. Then what I also described a bit in my introduction was the capacity profiles or the capacities. as mentioned there, we have now the possibility to define capacity on each location. So independent to which layer they have been assigned, we can use then also one or more capacity profiles. What now a capacity profile is, we will also see later how this looks like. So this is more or less only an ID to the capacity profile table that you can add. Plus, you have the possibility to also add more capacity profiles to the same location. Just separate them by semicolon. That's all. This is, for example, extremely useful if you have different capacity constraints for different products or different groups of products. So that's the idea behind this column. Yeah, so this is the location table. Next we are, so give me a second, I will put this a little bit down, that this is not confusing. Then the network structure. Network structure is important that you connect the different locations and make the connections in between. That's more or less the idea. Plus that you also define which kind of services. So this means trucks are available on these relations. In this case, I would say it's quite a simple model, because we connect here in this scenario only the plants, so the central DCs, regional DCs customers. Plus we could also add here now a direct layer, what I left out in this case, but you see you can do it quite easily. Plus you have the possibility either to work here based on the so-called location layers, or you could also put in there the location IDs from the first table. So this means it's up to you if you also decide for very fine-grained to decide for fine-grained modeling of the relations, how you connect your network. And this also comes then with the possibility that you can define which kind of service types are available on these relations. So this means, in this concrete example, all plants are connected to all central DCs with the so-called standard truck, 24 tons. And this standard truck has here 24,000 kilograms weight capacity, more or less. So this means if one truck is opened, more or less, you can, or the optimizer can also open more than one truck on a relation, then 24 tons weight capacity is available, in this case in 30 cubic meters in terms of volume. Besides that, you have the possibility then also to define on this relation what are the fixed costs if one truck is used or opened, or you can also use both. What are the costs per distance unit of this truck? Then in the background, the distances are calculated, and then it's also more or less a kind of fixed cost. So what does this mean? As explained, a product flow in this model is only possible if there is a capacity available. And you see it also here that this kind of capacity always comes with a fixed cost. So this means if there's a flow of 1 kilogram on such a relation, it means the complete truck has to be paid for the optimizer. So the optimizer has a very high motivation also to use the complete capacity of this truck, because he anyway has to pay it. And this exactly also leads us then to the point that the optimizer really tries to optimize also consolidation in the network, and use this economies of scale topic that you make a truck full and use the full capacity when you anyway have to solve it. This also makes it tricky for the optimizer, But in the end, it has exactly also the effect that you would like to achieve to have a very efficient network setup and also consolidate topics together. There's one additional column here. That's the minimum frequency. In principle, so this supply chain designer model is a static model. So this means explicitly there is no time dimension in this model. And so this minimum frequency column, it's an optional one. For example, if you have here now a time horizon of 8 weeks in there, so your planning horizon is 8 weeks, and you say, okay, when you open, for example, a certain relation, you would like to make sure that every second week this relation is then also opened or has a certain frequency, then you could put in there, for example, a 4. So this means then the optimizer knows, okay, when I use this this relation, then it's 4 times open. So I also then have to take care that it is idly 4 times utilized. That's the kind of modeling concept, how you can also bring in there, so this frequency topic in a static model. Besides that, it is also up to you, but I don't want to go there in any details. You could also then model a time-space network explicitly in you as a modeler, but then a location has then always a time component in there or period in there. So that's then this topic. So if you're interested in, you can also contact our customer success team. They will also help you, right, how to do that. But so the model, what you see in there, and it's obvious when you fill it in, is a static model. That also to be said. Good. This is the network structure. Then we have to define the products. So in this case, as said, we have now 6 different products in this case. We have here also the possibility, in the beginning I explained we have 3 different dimensions, so weight, volume, and pallets. And we have to define in this table 1 unit of a certain product has how much weight. So in the first case, 25 kilograms, 1 unit of this first product. And they're the same for the volume. You could also do it with the pallets itself. So that's what needs to be defined for the products itself. Plus, here we have the possibility to define valid and invalid paths. In this case, I'm only using, in this concrete example, only this path hazmat. That's also an ID that is then defined here in a path. And there I would like to spend a few words also how to explain how a path can be defined. You see it here, you need a path ID that is then also used in the products table. Plus you define here in a path with this arrow logic. So in this case, we have here the path hazmat goes from plants, that it is here a location layer. So this means from all locations, from the location layer plants to CDC in Frankfurt. So here you see we are mixing now location layers and locations. And then we go from CDC in Frankfurt to CDC in Munich, and then from there to all customers. So this means this is now a path that goes from all plants exactly through the network Frankfurt, Munich, and then to all customers. And this is then the only available path. And that's exactly what we did here. It is also possible to define multiple paths here, same as in the other table, just separated by semicolon. Then you can also use here multiple paths. Only be careful. Make sure that your network is still connected, right? So if you do there something that is perhaps not consistent, it could happen that source location is not connected to a sink location. So technically, no flow is possible between this location, and then the model is not feasible. You will learn this then also quite fast, but this can also happen, right? So with this past definitions, that's also something that you should be aware of. Plus, here it's now the past no Hamburg, I called it. This also means that from the central disease via Hamburg to the final customers, this path is not possible. And I used it, I think, then in this topic for this product, so for this polymers, so that they can't go via Hamburg. Could be, for example, the topic, so that Hamburg does not have the equipment and you would like to avoid that a certain path is not possible, and you can do it exactly like this. So there, I think perhaps take a few minutes when you go over that the first time, think about it. And also there, my recommendation is set up the first model with ideally as less constraints as possible, then review the first result, and then adding also complexity step by step. Don't try to add all the complexity in your first version, because then it can be quite tricky, right? If it is not solvable, or that you don't have the results. It's always a good strategy to start simple and then adding complexity step by step. I promised you that I will also tell something about this capacity profiles. You see here I have now different capacity profiles for the different locations. The naming is up to you, right? I called it, for example, here capacity in the Central Distribution Center Frankfurt. And I used just this ID when we go back here in this first table, cap CDC Frankfurt, and we connected it here to Frankfurt. So in this scenario, I only used also this one. The other one I copied there. So can also be used, but then you get different results. And I left them out now in the first scenario. Then we have it here. And there perhaps also you have a profile ID. Then you have here the product names. So this means you can leave this column empty. Then this means this capacity constraints is applied to all products. So empty means automatically it's applied to all. You can also, like here in the second one, it's then this capacity constraint is only related to this product that is named here. So this industrial coding. And you can also separate here multiple products also via semicolon. That's also possible. Capacity, you have to decide, is it now applied to all the flows that are going through this location, or only related to a subset of products. Then you have here for the 3 different dimensions, right? So weight, volume, and pallets. You have the possibility to set a minimum, a maximum, and here you can specify if this is a conditional minimum. For example, here in this RDC Hamburg, there is now the topic that we have a minimum weight of 40,000 kilograms. So this means either the flow is 0, that's also valid, or if you're using Hamburg, you have to you need at least 40,000 kilograms, right? So, or as throughput through Hamburg. That's exactly because we have activated here, so this conditional minimum here with this true topic. Plus, we also have here then the maximum weight condition in there, right? So this is, so what is now possible? Either 0 in this case, or a value between 40,000 and 250,000. That's it more or less. What does it mean, right? If these constraints are not fulfilled, then you have the possibility either to apply penalty costs per unit that it was not fulfilled. In this case, it is then 2.5 euros or optimization dollars, whatever you want, per unit. Is then also considered in the target function. So the optimizer has for sure a high motivation to fulfill this or to accept penalty costs. In this case, it is the so-called hard constraint. If you type in here a -1, then this constraint must be fulfilled. Then the penalty cost concept is not applied here. So this means if it is a hard constraint, either the optimizer is able to fulfill it or the model more or less is not feasible. So this means you will not get a solution. That's it here, right? It's quite a long table, but I think not that complicated because this is now just repeated multiple times. Here the same for the volumes, and here for the pellets. Principle exactly the same. And then last but not least, and then we also through, so this 6 tables, it's supply and demand, but it's also a very central table. So there you define where are products available. So here with supply, in this case, we have here our plants where that's more or less the source of the products. And there you can then define per location name and per product, what is the supply, what is there. And you have here also then the cost per unit. So here, for example, you could also then model this kind of situation when you can source the same product at 2 different locations or from 2 different plants or suppliers, whatever. And you can also then assign a different cost per product or cost per unit for this product. So this means the optimizer can then also make the decision, okay, which supplier should be used. And as mentioned earlier, you can then also include here minimum order quantities plus. Now also in this model, it is also available that you say, okay, a certain supplier only has a certain max capacity of a certain product, right? If you would like to do that. So this is, I think, gives you quite some flexibility what you can also bring in there. Besides the supply, for sure you need supply somewhere in your network. Otherwise, nothing can be transported or routed through the network. And on the other side, you also have to define which location is asking for which product and which quantity. So that's here the demand. And also there, you have then the possibility also define a cost per unit. But typically in the classical example, the demand, right? So then you don't have to pay something. You just our customer, for example, is asking then for something, but also there, for example, if it costs you something, perhaps it's waste, then you could also define her cost per unit to take this topic up, right, at a certain location. Then perhaps also this cost per unit would make sense here. In this case, not. And in addition to that, you also have here the same principle in with the penalty cost. Either you type in here a -1, then it's a hard constraint, so the optimizer has to fulfill it, or it is a soft constraint. So this means the optimizer has the possibility to accept penalty costs or not. Yeah. Now this was quite a journey. Sorry for that. Alex, do we have in the meantime any questions, or is there anything not clear? Then perhaps
so
also
there's no concrete question, but I think maybe what you also could explain is in the calculation, the parameters, the max solving time and the MIP gap, how this will affect the runtime. I think this is important and often came up with different other users that this concept is clear.
Yeah, good point. So coming now to the calculation, you connect all the tables. I think I don't have to explain that in detail how this works, same as in the other apps. And then, as Alex mentioned, we have 2 additional parameters, so the max solving time and also the MIP gap. Solving time, that's, I think, quite easy. The default here is 30 minutes. You also see, so this kind of models could run a bit longer. And then the solver stops after this amount of time and gives you back the best solution found so far. For sure, if the optimal solution is found after a few seconds, then it directly returns and gives you the solution back. If this is not the case, he runs here in this case for 30 minutes, and then the best found solution is given back. Then there's also this relative mid gap. So perhaps some of you know it. It's more or less the difference between the primal and the dual solution in such a mixed integer model. What does it mean in practice? It's more or less the worst case, how far away the found solution is from the theoretical optimum. But it's really the worst case. In lots of cases, right, you're much closer to the optimum, and we set it to a default value of 5%. So this means when the primal and the dual solution of this model is less than 5% away, so this means you're very close to the theoretical optimum. In lots of cases, it happens that you are already at the theoretical optimum, but the optimizer needs much more time to prove this, right? So from a mathematical perspective, so our feeling or our recommendation is for practical problems. So I think this 5% MIP gap is acceptable. You can keep it there, and there also, right? So for example, if we now reach a solution that is below 5% MIP gap, in less than 30 minutes, we also stop. So it's also a stop criteria for this topic, and return you the solution. Then we can run it. I think that's exactly the same. You just calculate it, distance calculation is done, or geocoding in the other case. And so then the optimizer runs, and then you have here also the result tables. And there, let me also perhaps spend a few words regarding this one. So there we have the output supply chain designer. I don't want to go there now in detail through every table, but to give you a high-level overview. Here in this table, you will find the product flows, right? So which product goes from which location, via which relation or layer to which destination, how much flow did we have there, how much weight, and so on and so on. So that's the very big table, and also corresponding costs and so on. So that's in there. The other topic is service flows. So these are the used trucks or the connections. So not only trucks, as said, you can also model here air connections, rail connections, or flight connections, whatever you want. So that's here the available capacity. So how many of a certain truck type, for example, you used on which relation. That's exactly what you find in here, then also with a kind of flow type. And what are there then the total costs. That's this information. So there, two tables, the two different flow types are covered, and you have all the details in there. Then we also added here an overview regarding the capacity profile constraints. So we see here, okay, all details that you need to understand what happened now with my capacity constraint. So was it used, was it not used? For example, in this case, we had a maximum weight of 800,000, and the assigned weight was 700,061, something like this. Then you also see, right, so was a capacity fully used? Was it not used? Was it considered, or were there penalty costs applied? You know, that you also can do this kind of analysis. Where do I need more capacity, for example? So this is what you can then learn from this table. Then here also supply and demand, right? So what was the available supply? What was the used supply? Same also with the demand, right? So what was the fulfilled demand? What was the required demand? And also what was the related penalty costs in there. So there you also then have this table to learn there everything regarding supply and demand. Helps you then also to navigate there much faster. Plus, what is, I think, also quite interesting is here, so the result KPIs, especially here also, so this achieved MIP gap in this case, right? It was super fast, but to be honest, it was also quite a simple example. So it only took a fraction of a second, and then here's the MIP gap. Here you also have the total cost, the product cost, service cost, and so on, what you also have in there. And then also the model inspector, there we also try to give you some insights, what we detected, what you should also then consider. So that's what we have in there. I just have to take a look a bit also regarding the time. Then, as you know, we have already seen the map. You can just click here, open new map. Plus also we have a dashboard available. That's, I think, similar like you know it. Give me just 1 second. I have to, is it here? Here we also have a dashboard available, right? So that you then also can save on the platform with some Sankey charts, supply and demand overviews. I don't want to go into detail, but there it also helps you. It's more or less a perfect visualization of what I just explained you there. That's what we have in there. What is not available yet is that you can directly save it. So this will also come in the near future, that you directly can save a scenario on the platform and then also do a scenario comparison. So there, the dev team is currently working on. So this will follow. Nevertheless, you could also then just save dashboard and map as you also know that. That's regarding this topic. And then give me just 1 second coming back to the presentation and then also closing it. Yeah, so here for sure, we also went a bit through the results. You analyze the different tables. For sure, take the time also to go in there and yeah, figure out what is exactly in. I think it's good also to spend a few minutes to get an understanding what is in there, the high level overview you have. And then, yeah, what also makes sense, as said in the beginning, start small, start with a small example, a basic example, that you get a first idea regarding your problem, then adding constraint or complexity step by step. And then it's always good also to see, okay, what is now exactly the effect? What is the difference? So save the scenario. Also take a look at the map left and right. So what changed? Does this make sense? Does this not make sense? And then for sure, you can also then run different scenarios. For example, you can close an RDC. So what happens, right? So if an RDC is, for example, down, or you can change a bit the capacities, the minimum order quantities. You could also, what I did there in this example, remove the direct delivery option. So just take out in this network structure table, just take out the direct relation. So what happens? So which way through the network is then used? Or you could also add an additional warehouse and do a kind of greenfield test. For example, in this case, what would happen if I open a warehouse in Italy? Is it used? Does it get enough volume, or do I need an additional capacity constraint? So this is now then also up to you, that based on your base model, you add on top different scenarios and then for sure compare them on costs, on other performance indicators, however you would like to do it. And you see, right, how you model it, it's really up to you. I think it's a good topic. Take the time, go over the model, think about it. Also think about how you could bring in your situation or your scenario in there. If there are any questions, feel free also to contact us, especially in the modeling. We are happy also to help, right? So come to our success team. If you are unsure or not sure how to model it, ask us. We are happy to help there. And yeah, I think so. A very interesting app that adds lots of additional capabilities to our portfolio, especially in this strategic network design topic, when you would also like to consider product flows in there. And yeah, so that's the starting point in this direction. We are also very happy if you could provide us feedback. That's always good to have. And yeah, so far so good from my side. Thanks a lot very much for the attention, for the time. And yeah, hopefully you could get a first overview regarding our new supply chain designer. And that's it so far from my side. Alex, question back to you. Is there any question open that we should tackle, or nothing so far?
There's no question open. Everything was answered. Thank you.
Okay, perfect. Hey, then thanks a lot for your time, for your attention. Have a great day, and yeah, talk to you soon. Bye bye.